All right, here are the slides. June 2016, famously known, the DAO was exploited. I wasn't a crypto guy back then, but I was starting to kind of get excited and watching the scene. It was extremely interesting to see how it reveals and opens up, because eventually this exploit was solved by a community doing the hard fork of Ethereum, which is very arguable but interesting way to solve the vulnerability. It kind of defined a lot of my past, how I joined the Open Zeppelin, because the Open Zeppelin mission is to protect the open economy, to make sure others are safe and they succeed in what they do. The way we do this, mainly we started with the open source contracts, which is our famous libraries, which now extends to other ecosystems, not just Solidity. We do a lot of audits on that to make that sure that implementation of that libraries is secure, and 200 is quite outdated number here. And the last not least is a Defender, which is our security services platform that has ability to monitor for the activity, do the incident response, and recently undergone through a major update. And you can do transaction management, you can do code scanning there, and actually get a full audit cycle inside. And doing all of this gets us to famous Murphy law. It's arguable, but we see it's happening. The vulnerability is happening, and actually you can express it mathematically. If there is a probability something goes wrong, or infinite time spent, it will go wrong. And when it hits the fan, basically, this is approximately how looks the management scheme for managing vulnerability. So we do these things, and these are the challenges we're facing, which you also can see on this diagram. I hope it's readable. So basically, most of that is focused about tooling we have today and smart contract methods we have today. And most of them are actually like pause contract or upgrade the contract, both of which aren't really super used. Like they are quite permissioned and not really like nice in the field where we're working at, because we need to something time critical yet decentralized and non-permissioned. But mostly today, if you're having like pause priorities, it's gonna be like quick action that Security Council will do, and the DAO, for example, doesn't have the time at DAO, has time to work on that relay. Here I want to outline a few things just to note for your attention for the next slide. So here the white hat rescue on the middle is a very important topic, and a lot of arrows you can see come into like when we manage the vulnerability into white hat rescues. And another thing to outline is that the disable vulnerability selectively is a shortcut. It's a magic button we actually want when we're dealing with vulnerabilities to disable the vulnerability. So why does this happen? Why we still have to work with vulnerabilities is that it's gonna happen. And private key infrastructure gonna fail. You know, yesterday on this stage there was words about not your keys, not your coins, but it's actually not your keys. It's private key underlying cryptographic primitive. It's just a number. Someone else might know it. And we also have a lot of blockchain hacking techniques, like compilers may fail, protocols are broken, contract infrastructure gets hacked, and just bugs in the contracts. We have a few of those. The coolest ones aggregated in our blog post, so we invite to check all of you for the coolest hacking techniques. The difference between vulnerability and just a contract bug, that you might have two perfectly safe contracts, right? But then you combine them together and this creates a vulnerable pattern. As we are getting more robust as an industry and more experienced, we actually are expecting to see less contract bugs and more infrastructure vulnerabilities where people are playing as illegal with the contracts on chain already. And we had these hacks last year, and it was quite nasty. Another thing to point out is that a lot of these are widespread. This means they affect multiple parties that are often peers to each other, and the managing such vulnerability is a tricky point. If you remember from the previous slide, the white hat rescue is important, but when you do the white hat rescue on a widespread vulnerabilities, you're exposing the attack vector and other parties might get affected. Now, if you are an ecosystem, let's say you're an ecosystem and you have vulnerable dependency, you have Bob contract, Alice contract, and Carlos contract, and Carlos figure out the vulnerability. Now, the responsible action for Carlos would be to actually have some ecosystem or security provider for the ecosystem who he can talk to and disclose this in a responsible manner, because he is not in the position actually to manage this kind of vulnerability. It's a level above him. And then an ecosystem provider should provide a mitigation strategy both for Carlos and for the rest community, do the complicated communication between all of these parties, which unfortunately right now happens mostly in Telegram, and then publish the disclosures. Now, the game theoretic model here is that problem is that Carlos actually is in a way incentivized to do the bad action to the ecosystem, and like he might do the some disclosure to the security provider, and we've seen this in practice. But he will be tempted to go to the social media and post about his findings, or even do like uncoordinated mitigation, which will expose the attack vector. And Alice and Bob and the ecosystem in general are not going to be happy about that. So he's fixing his own boat, but he's sinking the whole ship he's in. And the ecosystems have here an ultimate power to balance incentives. This is the first reason why he starts to do responsible disclosure, because the community is not going to speak to him anymore if he's in balance, right? So if you want to increase these incentives, you have a lot of actually abilities to do it even better today. Say if you're a layer 1 or layer 2 or any kind of ecosystem that relies to the users, and you can really write a good community code of conduct and actually utilize it through the grant allocation and build up actually here also experts in the field by packaging some experts through the grant allocations to the audit system. Then when the problem happens, you have a security provider who is experienced in your particular ecosystem, and then just help do the incident management, which Carlos cannot do, and do the media support in this time-critical moment when investors are panicking, users are in panic, and someone can step in as a trusted party and say, hey, we're handling this. So that was about today. The one thing I want, big thing I want to speak about is what do we see in the future, how it's going to evolve, and what we are looking forward. So, in my opinion, the smart contract security fundamentally relies on two main pillars, and one being the community principles. This is all of us. This is why I'm really happy to stand here in front of the community, because we are decent people, kind people, and we are building together the new world. And just this fact, and community goes beyond that, beyond the blockchain, the old mankind all together works. So the big backbone is this is amazingly working just because the community helps to do that incentive. You get the fund recoveries through the rating systems, which are maybe, let's say, forensics and law enforcement rating systems, but still, we could have more on-chain, we could have more responsible disclosure protocols, and we could have better community ecosystems codes of conduct. From the contract security pillar, I believe that security is an onion, which we have to think through and evolve into that. Next slide will be about that, but account abstraction is also changing a lot. Social recovery is something we explored, but say we're also able to define more user-centric security and asset ownership models through the account abstraction. I'll touch that later. And plan for these magic buttons to selectively disable vulnerabilities in a non-permissioned way. This is what we need in the future, as well as build some kind of secure apps and registries for audited infrastructures. Next slide. Here. So, security layers is something that is widely used in security beyond the blockchain. And today we rather need to anticipate the same, we need to anticipate that any method, even the public, in the infrastructure setup can become vulnerable. Therefore, we want to wrap it in authorization, authentication, check the message signature, and message sender when they are approved to do something, and have some layers for intrusion prevention systems and others in order to actually enable multiple orthogonal to each other parties entities to provide security for the smart contract infrastructure. And actually it's very good also architecture for developers, because if you are a developer, you're writing the state management logic and the logic of your application, you can kind of abstract away from security concerns for a minute and say I'm going to wrap it later on. Then the secure apps. That's this is the user experience today when you're interacting with the app. You have some asset, you have some DApp, you give the asset approvals, permissions, and it does something, whatever the app does. But it's missing here something, right? And this something is the trusted entities, actually. Because when you're working with a DApp, you actually are going to check, is this app secure? Is it legit? Did Vitalik yesterday mention this app? It's already plus in your rating. And you're gonna go in Web2 portals to check that. But you could also build these trusted entities, these trusted registries on chain, and also apps are using this to do the QIC or should do. So there is some initial work in that field, which eventually can evolve into standards. And I guess I just want to finish on account abstraction in that field. The thing here is that account abstraction is not about ERC 4327, but it's about the consensus we have as a developer community that the smart wallets, the soft contract wallets is the way to go. It's this is a standard we're gonna pursue. And if you take a look and say classical computer architecture, my background is more from computer architecture actually. The hardware is entrusted to the drivers. The drivers are entrusted to the operational system, which in its turn protects the user from apps to some extent. So you could define this same model in software wallet by doing the account abstractions as well, by splitting, say, asset storage from asset driving, which is ERC interfaces, which actually, say, ERC20 token is an interface. It's not the way how you store that. So you could split those. You could have user wallet, which is acting like this operational system, which encapsulates your resource access from the applications you install and use, the same way you have in a computer. And the same applies to secure registry, as secure slide, secure apps basically. And you could point that to the secure applications, implementations, and their storage. Now the cool thing about this is that every layer here can be wrapped in its own onion, and so basically, and arrows here is a trust flow, and you can actually set circuit breakers in every of these arrows, and hopefully in the future it gives us a huge security benefits over the architectures we're using right now, and eventually the hacks that will happen today, they don't anymore, cause a hard fork, but we also want to see them minimized and the impact, eventually to go to the minimal level and even below the Web2 industry. at least what we know about that industry publicly. Yeah, that's it. Thank you so much for attention. And if you have any questions or if you want to get these slides, feel free to contact me on email, and I'm happy to share more.